You expect flowers. You're going to get nothing, I'll tell you that. Nope. Here we go, the net change theorem. The net change theorem, the integral of the rate of change is the net change. What does that mean? The integral of the rate of change is the net change. So if we take the integral of f prime of x dx, we get big F evaluated at B minus big F evaluated at A. Now, that looks almost identical to what we've written before, only there is a slight difference. Anybody notice the difference? Again. F prime, right? So instead of writing little f, I wrote big F prime, which is the same as little f, isn't it? So the idea is that if we're given a rate of change function, we can find the accumulation, so to speak, by evaluating the integral. So what's a very common rate of change that you use every day in your lives? Miles per hour, so velocity. If we were to consider the integral of the velocity function, what do you take the derivative of to get velocity? Oh my gosh, okay. No, speed and velocity are nearly identical. Speed is just absolute value. You take the derivative of your position, your location. So the position, the location, the distance. So, you know, if you were to take the integral of a velocity function, you would find the total distance traveled over that interval, or that displacement over that interval. Okay, so it's very helpful. It's this accumulation piece. All right. If you know that snow is falling at a certain rate per hour, if you take the integral, you're going to find the total accumulation of the snow. If you know money is growing at a certain rate, if you take the antiderivative, you'll find the amount of money earned. You see what I'm saying? So the integral is very powerful in its applications outside of the abstractness that we see it right now in calculus. And that's why I changed the world. So this is, we're going to kind of just do a basic example today. You guys are going to try a couple problems like it. It's regarding a particle movement. And particle movement is a common thing that we like to talk about within calculus. So it moves at a velocity modeled by this. So this is the velocity function, okay? T is measured in seconds, and B is measured in meters per second, okay? So it says find the net change, or the displacement of the particle over the interval 1, 4. So from time equals 1 to time equals 4, the question is, what is its full displacement? Okay? We don't really know. All we have to do is take the integral for A and evaluate it from 1 to 4 of t squared minus t minus 6 dt. That will, in fact, give us the displacement. So again, as we talk about displacement, if I am standing right here and I walk to the door and I walk back, what is my displacement? 0. 0 is my displacement. However, what is my distance? Say 30 feet, something like that. Okay? Point. I'm going to say 32. I think it's 16 feet today. All right. So the point is that your displacement is different than the full distance that you traveled, correct? So we're just finding the displacement. How far is it from where it originally started? So I evaluate this. What's the antiderivative? Whoop. 4 to the third is 64 over 3 minus 16 over 2 minus 24 minus 1/3 minus 1/2 minus 6. 64 thirds minus 1/3. That will give me 63 thirds, which is 21. Minus 24. It's going to be a plus 6. Looks like we got a minus 8 there, and a plus 1/2. So let's go through this. 21 minus 24. -3 plus 6. 3 minus 8. -5 plus 1/2. -4, 1/2, or 9/2. Okay. So it's -4.5 units from where it originally started. So did it move backward or forward in the end? It moved a little bit backwards, okay? All right. The second question is find the total distance. Find the total distance that the particle traveled over the interval 1 to 4. So if I want to count for the total distance, I have to count for where it traveled in the positive direction, and then take the absolute value of where it traveled in the negative direction, correct? So we must consider the graph in this situation, all right? Yes, we're going to take the absolute value of the first part. So as we graph this beast, we have t squared. What? Did I miss something? My email? Oh. T squared minus t minus 6, is that factor? Yes, it does. T minus 3 and t plus 2. So I know it crosses through -2 and +3. It's a parabola. And the idea is that we want to find the displacement, the total distance traveled of this object from 1 to 4. So the part below the x-axis refers to when it's traveling in the negative direction. Part above the x-axis refers to where it's traveling in the positive direction. Because this graph of f of t, that's your velocity function, and where it's below the axis where the velocity is negative. Negative direction, positive direction. Does it make sense that when you combine these together, you'll come up with a negative value? Okay, so what I need to do is this, okay? I need to count this as positive. So what I'm going to do is I'm going to divide this up into two integrals. I'm going to take the integral from 1 to what? 1 to 3 of t squared minus t minus 6 dt. Is that going to be positive or negative? So I'll take the absolute value of it. And I'll add on to that the integral from 3 to 4 of t squared minus t minus 6 dt. No absolute value because we already know that's positive. So let's go to work. Antiderivative. T to the third over 3. T to the third over 3. If I plug in 3, I get 9 minus 9/2 minus 18 minus 1/3 minus 1/2 minus 6. 9 minus 18, -9. Plus 6, -3. See, -9/2 and minus the -1/2. -8/2 or -4. And then minus the third. So I've got -7 and 1/3 or -22 thirds. Now, we want to count that as positive or negative? Positive. So 22 thirds. Plus, now we need to do this integral. t to the third over 3 minus t squared over 2 minus 6t evaluated 3 and 4. Plug it in. Get 64 over 3 minus 8 minus 24 minus 3 minus 9 over 2 minus 18. What? Whoops, sorry. Thank you. 9. Okay. So negative 8 and negative 24 make negative 32. Minus 9, negative 41, plus 18, negative 23. Very good. So plus 64 thirds. That'll be plus 9 halves. Turn this all into sixths. So 23 times 6, negative 138. So negative 10, positive 27 is 17 over 6. Did we know that was going to be positive? So for our final answer, we got 22 over 3 would be 44 sixths plus 17 sixths is equal to 61 over 6, which as a decimal should be that. Total distance traveled. Now, watch, because on the AP Calculus test, they're not going to probably ask you to do that. They'll say, what's the net distance traveled? Or what? No, not the net distance. They'll say, what is the displacement? No. What is the total distance traveled? And what you'll do is, what you want is you want the absolute value of this function and its area. So you want that part. So all you have to do is, on the test, you would go to your calculator. You turn on. Go to y equals, and I type in the absolute value. So I type in ABS of x squared minus x minus 6. And I go second calculate, and I evaluate 7 from 1, 4. It does exactly what I want it to. Oh, yeah. No, it isn't. Give me time when you get back. You have the rest of the hour to work. Because I'm a nice person. Oh, for YouTube Nation, in case you want to work out some problems, here it is. There you go.